Now let's understand the basic equivalence of Cartesian and polar coordinates. Now we require two coordinates for a planar representation in Cartesian coordinates, that is x and y, and similarly we require r and theta for representation of a curve. Now how do we actually go about this? Now from the figure you can clearly see that a point characterized by coordinates x and y is considered, and I have joined that to the origin so that I can seek the magnitude of that line, that purple line. So what is the magnitude of that line? That is given by root of x square plus y square. This is from the distance formula, because this has coordinates 0, 0, this has got x, y, and this magnitude is nothing but r in the polar coordinates. That is, if you join any point to the origin from where you are incepting, because r can vary from 0 to infinity, so this represents the magnitude of r for any polar curve. And then what about x and y? If I project this radius onto x-axis, that is, if I am talking about r cos theta, then that would give me x, right? And what about y? If I project r onto the y-axis, because this angle is going to be 90 minus theta, so therefore cos of 90 minus theta, cos of 90 minus theta is equal to y, and that in turn could be written as r sin theta, and that is equal to y, right? I have got expression for x, I have got expression for r, I have got expression for y. So therefore if I sum it up, I would get the following, that is, r is nothing but root of x square plus y square. This is important. Now you also have r cos theta is x and r sin theta is y. These three equations are important and very easy to remember also, so that these can be used in the further discussions when we are converting from Cartesian to polar or polar to Cartesian. So this is very, very important. So r is nothing but the magnitude of or the distance from the origin to the point, and r cos theta is x and r sin theta is y, because we are reckoning the angle with respect to positive x-axis. So these are three things that you may want to note. And if you want to express cos theta, you can express it as x by r and sin theta as y by r, and you know the value of r, so that in turn also justifies the properties of this small right angle triangle. So with that we will move on and try and convert a few typical curves, let's say parabola or a circle, from Cartesian to polar. So let's move on and look at those discussions.